Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Sunaira Iram is here, your chemistry teacher. I welcome you all in e-learning project of Chenab College, Jung. I hope you all are fine and enjoying your vacations in this holy month of Ramadan. Before starting the proceedings of our today's lecture, I would like to discuss paper pattern section wise along with its marks distribution. As you know, the paper pattern is similar to that of part 1 as it carries 85 marks. It consists of 3 sections. Section A comprises of MCQ type questions. Each MCQ carry 1 mark and there is no choice in this section and you have to complete it in first 20 minutes. After you complete section A, you will be given the subjective type of paper. In this paper, there will be 2 sections, section B and section C. Section B consists of 3 short questions that carry question number 2 and question 3. It have 12 parts, out of which you have to attempt 8 parts, and question number 4, it consists of 9 parts, out of which you have to attempt 6 parts. Each part carry equal marks. The last section, that is section C, it consists of 5 long questions. Each question is of 2 parts. You have to attempt 3 questions out of 5. That was all about your paper marks distribution. Now come to lecture 1. We will take a start from chapter number 7 of your second year class. Your chemistry syllabus, it consists of total 16 chapters. First 6 chapters, they belong to inorganic chemistry, from chapter number 7 to chapter 14 organic chemistry. Chapter number 15, that is from industrial chemistry, and the last chapter having some topics from environmental chemistry. The major portion of your paper, it comes from organic chemistry. So for the sake of your convenience, we will take a start from chapter number 7, that is fundamental principles of organic chemistry. We start our lecture by introduction of organic compounds. In this chapter, we will discuss some fundamental principles or some properties of organic compounds. Firstly, we will start from the history of organic compounds. Almost 200 years ago, the early chemists, they separated organic compounds from inorganic compounds due to the differences in their origin and properties. So chemical compounds, they are of 2 types. If we divide the chemical compounds on the basis of their origin means from the source from which they are obtained, there are 2 classes. One is organic compounds and the other one inorganic compounds. Organic compounds are those compounds which are obtained from living things, that are basically plants and animals. For example, butter, cheese, cotton, silk, glucose. While inorganic compounds, these are the compounds which are obtained from non-living or mineral sources. For example, sodium chloride, calcium carbonate, sulfuric acid, and many other large number of molecules or compounds that are inorganic in nature. So that was the previous concept that on the basis of origin, organic compounds were those that were only obtained from living things. In this concern, we will discuss a theory that is vital force theory. And this theory was given by a scientist whose name was Johannes Jacob Berzelius. In 1808, he gave this theory, and he was also known as the father of organic chemistry. This theory is also known as bioforce theory. The word vital means important. It is a supernatural force that is found only in the living things. According to him, according to this theory, he said that we cannot prepare organic compounds in the laboratory, or organic compounds can only be manufactured by and within the living things. So it was said that organic compounds, they could only be obtained from living things, and they can never be synthesized in the laboratory. That was about the vital force theory. Other scientists, they supported Berzelius, and he suggested that we should study organic chemistry separately because they have unique properties. Then introduced a new branch of chemistry which is known as organic chemistry. So according to J. Berzelius, organic compounds can only be prepared by the living things because they have vital force, and that vital force is an inherent force that is present only in the living things. That was the concept given by Berzelius, and this theory is named as vital force theory. But later on, a scientist came whose name was Friedrich Wöhler. He was a German chemist, and in 1828 it was the time that was the breakdown of vital force theory, or he rejected the vital force theory. How he rejected the vital force theory? He rejected this theory by preparation of organic compound, that was urea, in the laboratory from an inorganic compound. So urea was the first organic compound that was synthesized in the laboratory from an inorganic compound by Friedrich Wöhler. He was actually preparing ammonium cyanate, NH4CNO, from ammonium chloride. The reaction is given here: ammonium chloride plus potassium cyanide, they combine together to form ammonium cyanate and potassium chloride. NH4Cl plus KCNO, they react together to form ammonium cyanate plus potassium chloride. But he heated it much, and then a rearrangement reaction took place which formed urea. The reaction is given here: NH4CNO, on heating it converted into urea. Ammonium cyanate, as you know, that it is a typical inorganic compound of mineral origin, while urea, it is a well-known organic compound, and that compound, as you know, that it is found in the urine of mammals. Since the synthesis of urea, millions of organic compounds have been prepared and analyzed. There were some other scientists that prepare millions of organic compounds, acetic acids, methane, and many others. They were prepared by the scientists, and they were analyzed in the laboratory. In this way, organic chemistry made progress by leaps and bounds. So, according to the Wöhler work, The new or modern definition of organic compounds can be done in such a way that all those compounds which contain carbon as an essential element, along with hydrogen, oxygen, nitrogen, sulfur, phosphorus, halogen, etc., they are called organic compounds. For example, glucose, methane, benzene. But there are some examples of such compounds that although contain carbon, but they are not included in organic compounds. There are few exceptions. For example, carbon monoxide, carbon dioxide, carbonates, and bicarbonates. These are those compounds that although contain carbon, but due to some historical or conventional reasons, they are not studied as organic compounds. They are known as inorganic in nature. In the same way, diamond and graphite, as you know, that they are the allotropes of carbon. So carbon is the main component of these compounds, but instead of this, they are not included as, or they are not known as organic compounds. Rather, they are named as inorganic compounds. It has also been recognized that the chemical forces in organic compounds are similar to those which exist in inorganic compounds. So, the modern definition of organic chemistry is done in such a way: the branch of chemistry that deals with the study of compounds of carbon and hydrogen, that are basically hydrocarbons and their derivatives. Derivatives means those compounds of hydrocarbons that are being derived from them. They include alcohols, alkyl halides, esters, aldehydes, ketones. You will discuss all these derivatives in your upcoming chapters. So, the modern definition of organic compounds is that those compounds that consist of carbon and hydrogen, mainly the carbon and hydrogen, are the main component of all the organic compounds. At the end, we will discuss importance of organic compounds. As you know that organic compounds, they are very much important in the life of living things. Some life molecules such as proteins, carbohydrates, vitamins, lipids, enzymes, nucleic acids, they all contain thousands of carbon atoms. Our own life depends upon organic compounds present in food, medicine, and clothing. We all are dependent upon organic compounds. Our daily used substances such as paper, plastic, rubber, drugs, paints, dyes, medicines, varnishes, synthetic fibers, detergents, pesticides, and cosmetics, they all are organic in nature. These synthetic organic compounds, they fulfill the shortages of natural products. In this way, we can easily judge how organic chemistry is important in our life. So that was all about today's lecture. It was a very brief introduction about organic chemistry. I hope you all understand it very well. You are also advised to learn your lecture on daily basis and make yourself ready for the test. In today's lecture, the most important thing was one of the question, that was vital force theory, or you can say importance of vital force theory, and the other question was Wöhler synthesis, or the question may come in such a way that how vital force theory was rejected. These two short questions are very important from this topic. God bless you all. Allah Hafiz.